Hi everyone, welcome to the classes on fluid machinery. Today we will be discussing reciprocating air compressor and we will be discussing some numerical problems today. So we have already completed the theory part regarding the reciprocating compressor with and without clearance volume. Also we have derived the equation for volumetric efficiency. So now we have the equation for power, work done, volumetric efficiency are known to us. So we will start the problem with a previous university question, that is a question asked for the KTU in the year of 2017. A single stage single acting reciprocating compressor. So it's mentioned single stage single acting reciprocating compressor compress 7 into 10 raised to minus 3 meter cube of air per second, that is VA is given as 7 into 10 raised to minus 3 meter cube per second. From 1.0132 bar, P1 is given as 1.0132 to 14 bar, P2 is given as 14 bar. Index of polytropic compression, small n, is given as 1.3. And the mechanical efficiency, that is already discussed, it is the ratio between the input to the compressor and output to the compressor. Is 82%, that is 0.82. If the clearance is 3%, clearance means it's the ratio between clearance volume and substitute volume. Vc by Vs is 0.03. Determine the volumetric efficiency. We already know the equation for volumetric efficiency. Power required. Power is given by work done into RPM. And show the process on a PV diagram. We have to draw the process, that is a reciprocating compressor, and it is mentioned the clearance as percentage. So it is a reciprocating compressor with the clearance volume. So we have to go with the indicated diagram of a reciprocating compressor with the clearance volume. So we'll write in the given data first. First of all, they have mentioned the volume intake. It is actual volume, that is 7 raised to minus 3 meter cube. Normally volume is expressed in meter cube, as they have mentioned as meter cube per second. That is, the volume is multiplied by RPM. Okay, that's why its unit is converted into meter cube per second. Normally the volume unit of volume is meter cube. As it is converted to meter cube per second, it's already multiplied by the RPM. That is, RPM is rotations per second, so it is multiplied by RPM, you will get meter cube per second. Okay. And P1 is given as 1.0132, that is into 10 raised to 5 Pascal or into 10 raised to 2 kilopascal. P2 14 bar 1400 kilopascal. Small n is given as 1.3. Mechanical efficiency is given and the clearance ratio is given as 0.03. So first we have to calculate the volumetric efficiency. So we got the equation volumetric efficiency equal to 1 plus C minus C P2 by P1 all raised to 1 by n. So C is the clearance ratio. That's already given in the question. It is 0.03. And P2 and P1, pressure at the inlet and pressure at the outlet. As we are taking the ratio, we are not bothered about the unit of P1 and P2. So either you can substitute in bar or you can substitute in kilopascal. The next thing we have to calculate the power. For power, we need the equation for work done. Work done is given by n by n minus 1, P1 VA, P2 by P1 all raised to n minus 1 by n. So we are checking the values. N is given, P1 is given. We will be substituting P1 in terms of Pascal. Okay, Pascal or kilopascal. If we substitute P1 in Pascal, we will get the value as joule as the answer for work done. If we are substituting the value of pressure P1 in kilopascal, we will get the value of work done in kilojoule. And VA, next term is VA. VA is the volume. Normally we will be substituting the volume in meter cube. Here it is given as meter cube per second. That is, VA is already multiplied with the RPM, n by 60. RPS, normally n by 60. So, already the work equation is multiplied by n by 60 if we are substituting the VA in meter cube per second. Normally the unit of volume is meter cube. As it is given, it is meter cube per second. So VA is already multiplied by n by 60. So if we are substituting VA in terms of meter cube per second, we will be obtaining the value of work done as kilojoule per second. Kilojoule per second is the unit of work done, or it is a kilojoule per second equal to kilowatt. So as the question, we have to calculate the power required, that is W into N by 60, which will already obtained from this equation itself. Why? Because VA is substituted in meter cube per second. So we will substitute the value of VA and we will substitute the P1 and P2 and we will get the value of W. And the last thing, we will calculate the power. And we have to draw the process. Again, there is a 1 to 2 is the compression, 2 to 3 is the delivery, 3 to 4 is the expansion, 4 to 1 is the suction. Okay, we will go through the answers. These are the given data. First, we will calculate the clearance volume. We will substitute the value of C as it is given is 3% of the Vs, that is 0.03. So we will get the volumetric efficiency as 0.8. To convert it into percentage, multiply by its 100. So we will get the value of volumetric efficiency as 80.39%. Okay. Next thing, we have to calculate the work done. All the values are known. Small trend polytropic index is given as 1.3. P1 pressure we have given as 1.0132 bar. We will be converting into Pascal. So we will be writing in kilopascal. And VA, it is given as 700⁻³ meter cube per second. Normally we will be writing meter cube, as it is meter cube per second. We will be obtaining the unit as kilojoule per second or kilowatt, which is a unit of power. So directly we will get the answer for the power. Okay, we will discuss one more question. A single cylinder single acting reciprocating compressor with a bore and stroke. They have given the diameter of the cylinder and stroke length. From that we can calculate the swept volume of the cylinder. Okay, runs at a 410 rpm. Capital N is given. At the beginning of the compression, pressure and temperature in the cylinder are, that is P1 and T1 is given as 0.98 bar and 40 degrees Celsius. The delivery pressure is 6 bar. P2 is given as 6 bar. The index of compression, small letter n, is 1.32. And the clearance Vc by Vs is given as 0.06. Determine the volume of air delivered with respect to 1 bar and 20 degrees Celsius. They have mentioned in the beginning of the compression, pressure and temperature are 0.98 and 40 degrees Celsius. So we have to calculate the amount of air delivered with respect to another condition. So in this case, we will be using the equation for free air delivered. And the second thing, we have to calculate the compressor power required. As it is a single acting compressor and with the clearance volume, we will be using the equation for power. So we will be writing the given data: diameter, stroke length, RPM, P1, T1 and P2 and VC, P0 and T0. Okay. P0 and T0 are the atmospheric pressure and temperature. As it is not given, you can assume the value of 1 bar or 1.01325 bar and temperature as 27 degrees Celsius or 22 degrees Celsius, depends. You can assume a value between 27 to 22. So normal atmospheric temperature condition. Okay. First thing, we have to calculate the free air delivered. So we will be comparing the atmospheric condition with the outlet condition or with the inlet condition. You can compare both, either with the outlet condition or with the inlet condition. So that is free air delivered. This is the thing they have asked. They have mentioned V0 in some textbook. In some textbook it is mentioned like that, VFAD. And the PO and TO are the atmospheric temperature and the pressure. So we can either compare it with the outlet condition or compare with the inlet condition. Whatever the data is available, we can use the available data. So here I am using VA, that is inlet condition. I am comparing with the inlet condition. So what are the data available? So PO is given, TO is given, P1 is given, T1 is given. VA, A we don't know. A is the actual volume. We know that volumetric efficiency is the ratio between actual volume and swept volume. The equation for swept volume is pi by 4 d square into L, where d and L are given to us. So we can calculate the value of swept volume, and if we know the value of volumetric efficiency, we can calculate the value of actual volume. The equation for volumetric efficiency is 1 plus C minus C into P2 by P1 all raised to 1 by N, where C is the clearance ratio. It's already given in the question as 0.06. So you can calculate the value of volumetric efficiency. The volumetric efficiency is the ratio between clearance volume and actual volume and swept volume. So swept volume can be calculated by pi by 4 d square into L. So multiplying volumetric efficiency with the swept volume, you will get the value of actual volume. If you got the value of actual volume, you can calculate the value of VFAD. That is our first thing we have to calculate. Air delivered with respect to temperature 1 bar and 20 degrees Celsius. Over. The second thing we have to calculate the compressor power. That is N by N minus 1 P1 VA P2 by P1 all raised to N minus 1 by N. Where VA is the actual volume. That is already calculated for the calculation of VFAD. Substitute that value here, you will get the value of power. So our answers are 2.25 kilowatt is the answer for the power, and the value of VFAD is 0.00135 meter cube. So please check whether you are getting these answers and complete in your notebook. Okay, we will be discussing more problems in the coming classes. Thank you.